Are you guys sick of long nights like this? Then this is the video for you.
My name is Kat. Welcome to my video. We're going to be talking about binomial distribution and binomial theorem. So if that's what you were looking for, this is the place. Although it might seem a little complicated at first, we're going to take it step by step, and hopefully at the end of it you'll learn something. To start off, we're going to start with binomial distribution. And binomial distribution is a type of probability distribution, but it can only exist within like certain conditions. So the first condition we're going to talk about is that each trial has to have two possible outcomes. These two possible outcomes are usually identified as your success or your failure, and this is kind of like, don't get too lost in like the way that's phrased, because this is like an umbrella of terms. So you could have red pill, blue pill, Arsenal, Liverpool, green eyes, brown eyes, political candidate number 1, political candidate number 2. Essentially what you have is there's one choice you do want to get, your success, and there's one that you don't, and that's your failure. The second condition we're going to look at is that the trials are independent of each other. And so what that means is that they don't have an effect on each other. And a good way to think about this is a coin toss or a coin flip. So when you have a first attempt at like flipping a coin, let's say you get heads. Well, that has no effect on if you were to flip the coin again and you get tails or heads. The first attempt had no influence on that. The third thing we're going to look at is that the probability of success is the same for each outcome. And so basically what that means is that the probability of success is locked in. So if it's like a 10% chance of getting green eyes, that's going to be the same for the entire event. The fourth thing that has to be true is that the total is fixed, or like the number of trials is fixed. So basically that's like locked in as well. And so that's essentially just like if in a problem it says, oh, it's out of 10 dice rolls or out of 10 attempts. That's basically like what it's saying. And so in summary, to kind of just put all the conditions into like perspective, you have an experiment or a trial, or you can just think of it as an event with two possibilities, your success or your failure. And this is repeated a certain number of times, and you're looking for a particular number of successes. And that's basically what each of these have outlined to us. And also each of these conditions sort of provide a variable that we'll learn about next when we talk about the formula. So now that we've talked about the different conditions that help decide if a problem is a binomial distribution problem, we're going to look at the binomial probability distribution function, and that's represented by this formula. So it's the probability of random variable x equaling r, which is our number of successes, and that's equal to n choose r times p raised to the r power, and then times 1 minus p raised to the n minus r power. And so what we're going to do next is we're going to look at what each of those variable means, so that you're able to pick those variables out from any number of problems. To start off, we're going to look at this function notation. Many times you might see the binomial distribution problem start off like this. And so you might get a random variable x, and you'll have this b. That's representative of binomial probability distribution function. And then you'll have the n and the p. And so that segues into figuring out what each of the variable means. So the first variable we're going to look at is at p. And p is the probability of a success, so of an event being a success. 1 minus n is like the probability of an event being a failure. N is the number of trials, so like the total number of trials. R is the number of successes. And so together all of these work to be placed into this formula up here. The final piece of like Another formula we're going to look at is the mean or the expected outcome formula, and that's represented by mu, and that's equal to n times p, and it represents the same variables as above, so n is equal to the number of trials and p is equal to the probability of successes. So next we're going to do a couple of examples to just kind of make sure everything makes sense. So we're going to move on to our example here. So our example says, Melanie is a doctor that specializes in genes. She is consulting with the Che family, which carry both a brown eyes and a green eyes gene. The probability of any future Che child getting green eyes is 15%. Alright, so to start off, we have the question, if the Che family has 5 kids, what is the probability 3 of those kids have green eyes? So our first step is going to be, is it a binomial distribution problem? And we're going to figure that out. And you don't always have to do this, but it does help. It's going to be intuitively that you'll end up knowing how to do this, but it does help identify the variables. So to start off, it says, is there 2 possible outcomes? And yes, we have green eyes and brown eyes. There's only 2 options. And then it also asks, is it a fixed probability of success? Yes, our probability of success is 15% because we're looking for green eyes. That's our success. Number of trials, so is that total fixed? And yes, because we're looking for we have a total of 5 kids. And then is it independent? It is independent because having a child that previously had brown eyes does not affect the child's ability to have green or brown eyes. To continue, we're going to go into step 2, which is identifying the variables. And by doing this first part, we kind of already did that. So just to confirm, our n, or our total number of outcomes, is 5. Our probability of success is 0.15 or 15%. And then r is 3 because that's the number of successes we want, 3 kids. We're going to substitute what we know into the formula. And so we have the original formula here. And then we're just going to make it so that it's the probability of random variable x is equal to exactly 3. And so we can use our calculator here. And so we can go to second vars. And then we're going to go to binom PDF because we're looking for an exact answer. And so we have a total of 5 trials. And then our probability of success is 0.15. And then our x value is 3. And then we're just going to paste. And then we get that it's 0.024384 and so on. But we want it rounded to 3 significant figures. And so you get 0.024. Or if you wanted a percentage, it can be 2.44% chance. We also have a second part to our example. So the second question asks, the Che family has 7 kids. What is the probability that at most 3 will have green eyes? Now here it's really important to pay attention to word choice because it does say at most. So again, we can go through the first step where we can identify if it's a binomial distribution problem, but at a certain point it will be intuitive, so we can go right into identifying the variables. So n, or the total number of trials, is 7. Our probability of success is still 0.15, and our number of success is still 3. We're going to plug what we know into the formula, but this time it has changed a little bit because the probability of random variable x is now less than 3 because at most is what we want. And so now for the calculator, it's going to change a little bit. And so we're going to go again to second vars. And then instead of binom PDF, since we're looking for less than, we're going to use CDF because we want everything that's less than. And so now there are 7 trials. The probability of success is still 0.15. And then the x is still, or the x or the r is 3. And then we just paste. And then we get that that's equal to 0.9878 and so on. But we want that to 3 significant figures. And so we can get 0.988, or we can get in percentages, it would be 98.8%. Is one final part to this example. It asks, Miss and Mr. Che plan on having 19 kids. If they have 19 kids, what is the expected number of green-eyed kids? So our first step, So there is a third question to this. So it asks, Miss and Mr. Che plan on having 19 kids. If they have, well, they do have 19 kids, what is the expected number of green-eyed kids that they have? And so to start off, we have to identify this as an expected outcome problem or like a mean problem. And so we're going to end up using the formula mu is equal to p times n, or probability of success times number of trials. And so then we're just going to identify our variables. So our probability of success is still 0.15 and our n is now 19. And so then we're just going to substitute, we're going to plug in those numbers, and we're going to get mu is equal to 0.15 times 19. And we get that that's equal to 2.85, but you can't have 2.85 kids. So we're just going to round to 3 kids. All right. Finish off, we're going to do this, or you guys are going to do this assigned problem. So to read it off, it says, Cynthia is a huge The Weeknd fan, so she decides to enter a contest to win a pair of tickets for his show. In order for a chance to win, she has to take a 15-question multiple choice test. Each question has 6 possible answers, but only one is correct. The catch is that the test is on Canadian history, so she guesses on all of the questions. So the first part is, what is the probability she answers exactly 3 questions correct? B is, what is the probability that she gets at least 1/3 of the test correct? And then C asks, what is the probability she answers at most 7 correct? And then these would be the answers for Cynthia's problem.